from APH10. We're going to go through a session today of securing software supply chain, which is pretty critical, I think, for what most companies do. We've got a problem, most companies have a problem in knowing where their software is, how much they've got, where it's come from, and so we'll have a nice session from Anthony about what to do about all of that. So with no further ado, I'll hand over to Anthony.
Thank you. I've got a lot of slides because it's a big topic. Okay, so yeah, I'm Anthony. I'm a startup, but I had 40 years in the industry, so I understand complex software and I understand some of the challenges. So, a bit about me. I founded a company 18 months ago after having 40 years in corporate life, and COVID just said I wanted to do something different. But I also do, I like giving back, so I also do mentoring of the next generation, my retirement plan. So I'm a STEM ambassador. I mentor students for Google as part of the Google Summer of Code. So I work as an open source architect developer for a project, and we get engineers from all over the world helping us, and that's great fun. I also teach code, the next generation in Python. I do generally Python, but I do Scratch as well. Again, I try and teach coding the way that we would like to use it in industry. Secure code, because that's where all code should be secure. I also like running out muddy fields at this time of year. And that B is Manchester. Manchester tech ecosystem has been my home for the last 12 months, giving me a lot of support. And I've been evangelising this topic for the last 12 months, and I'm now getting people talking about it. They say, go and see Anthony. And that's really where it wants to be. So, what's the supply chain? This is the definition. It's all those words, but I think the important word is a network. It's companies and people, organisations and people. It's not just one or the other. And we are producing and delivering things. And that's actually quite important, because if we recognise a traditional supply chain, go and get your wheat from your field, it gets put in a shed, then gets shipped to a manufacturer, and a bit of production gets made into something, ends up in Tesco's, and then it ends up in your biscuits at home. That's quite a traditional thing, but we're aware of all what the challenges are, how that can be disrupted. You can disrupt the field at the start of it, so if there's nothing in the fields, you've got no biscuits on the shelves. Or you can get problems with manufacturers, and we are well aware of the global supply chain challenges we had in COVID. So let's look at what software looks like. There's a software engineer. Could be anywhere. Could be doing this on their own, part-time. Could be doing it for fun. But then increasingly we're starting to see what we call foundations, which basically encourage people to actually write software that the world needs, and they try and curate that, and we'll see that a bit later on in some of the things that their initiatives they're doing to try and make software professional. And then you get people that then acquire software from these various sources, as well as licensing software. They will get software from third parties, your Red Hats, your Microsofts, your AWSs, choose your favourite supplier, and it then goes to somebody who's going to use it. That's your, maybe a system integrator, a production. It might be part of your production facility, your IT department, and enter it, ends in, and then the user can use it. So I think the supply chain here is from a developer to maybe a foundation to what I call a consolidator, which is what Microsoft is. You didn't think they were going to consolidate it, you probably thought there was something else, but I think they just consolidate software. And then people take their software and make things, which is what the integrator does, and an end user or customer uses it. There's a lot of people there, a lot of moving parts, and it's complex because you don't understand it. Because if somebody changed, are you aware? Or if someone stopped writing software, are you aware? So, if you think now what code looks like, when I started writing code, didn't have anything like libraries. I wrote all the code. We wrote operating system, we wrote everything. These days you write a little bit of code and you build in libraries, other facilities that other people have written, and you benefit from that. And I saw this morning, which I thought was really interesting. Has our software become too big? Software is now quite exploded. Why have our PCs got terabytes of storage and RAM? Because we want to store lots of stuff, and all our applications are getting bigger, our games get bigger. This was a lecture which was quite interesting. It was written as a Nicholas Worth died a few months ago. He was the guy who invented Pascal. Pascal was the language I learnt at university. And Pascal was a really small language. It didn't have any libraries. You had to do, all you could do was whatever was in the library in language. Don't do that now. You're not constrained by a language. And if you look at numbers, software by numbers now, 90% of every bit of software uses somebody else's software to help deliver that functionality. Whether that's your word processor or whether it's a little thing driving a little widget in a sensor, 90% of the software applications will use third-party components. And people get things wrong. That's the number of vulnerabilities that were discovered in 2023, which was 15% more than 2022. So that's growing. Now, is that because people are getting better at writing software or worse at writing software? Or we're getting better at detecting software vulnerabilities? I don't know. That's a problem for people to try and keep on top of. If you get it wrong, that's how much it will cost you business. That's about the best figure I could find. $30 million pounds for the cost of data breaches or ransomware in a year. So we need to do something about that, because the numbers are now so great that we can't keep control. And the reason is this is all about risk. And if you don't know what's inside your software, how do you know what the risk is of that software? Just think about that. Every business is a risk-based business. The risk to their staff, the risk to their customers, the risk to their shareholders. Business is risk. Software helps that, or influences that risk.
What's the impact of things like open source against closed source?
Hold on, Dave. Take slides later.
Okay.
We'll get there. But you're right. The ecosystem of the software industry is now very, very dynamic. So let's see what happens when it goes wrong before we work out how to make it right. Here's a better Equifax. Probably in 2015, no one knew who Equifax generally. It was just a company that just did things. Then in 2017, they had a data breach. It cost $2 billion. This is just the US figures. It costs more than that probably outside. 140 million customers were affected, and it took them 78 days to find, or 76 days to find. You really know why? Because they were using an out-of-date piece of software that they didn't know they were using. You could say that that's a very good way, and now everyone knows Equifax are, so it's a great way of getting your publicity, but it's the wrong type of publicity you want. And you're going to see later on, that type of publicity is now not good for you, if you're a senior exec. Who remembers Lock the Shell? Lock the Shell is probably one of these landmark vulnerabilities that I think is going to have a significant change on the way our industry is going forward. So Lock the Shell was a vulnerability in a piece of Java that is using 8% of all Java applications, and there are about 3 billion Java applications around the world. So that's a lot of applications, and most people didn't know who were using it. You can tell it's an important vulnerability because it's got a name. US government set the dictate a week after. Nobody in federal government can be off for Christmas until they fixed it. That was the level of seriousness that they took it. They didn't fix it by then, but you'll see why later on. But that was the level of seriousness that the federal government got worried about, because potentially it was so used in so many systems, they felt that basically that could have significant consequences. Or you could have a new one, which happened a few weeks ago. Again, it has names. If anyone's using containers, that's a container breakout. Maybe not quite as prevalent. I hope people are a bit better at being able to solve that. Maybe that's why it's been a bit quieter. Or you could have people who basically start changing software that's on GitHub. And because of the way people were building software, they were just downloading the latest version. The latest version actually had a little denial of service attack, and nobody noticed. 27 million people downloaded it, 27 million downloads in a week. So that expected 27 million applications or organisations were affected. And people weren't watching that. Or you can play little tunes in your development practice in terms of having something that's private in your organisation and something that's public, and there are ways of confusing that. And malicious attackers will use that, will play that to their advantage. So when a vulnerability happens, is that what you like? Any IT departments, CISOs or whatever, is that the things? Oh yeah, well, 5 minutes, well, no problem. Most people are like that. That's what happened in Lofagel. Very few organisations were able to just say, we know exactly where that is, because it happened at 3 o'clock on a Friday afternoon when I got told about it. Most people, it just was ballistic across all the social media channels. No one had got a clue. That's the problem. Nobody is in charge. So the US government decided they needed to do something about it. So April 2021 is quite interesting. So this is new president. There was an incident in December 2020 called SolarWinds, which was an attack on the supply chain that infiltrated software that ended up affecting the federal government. So they weren't very happy. So they said, how do we stop this? It was assumed to be a state actor doing this. So they wanted to say, how can we protect our citizens? This is very, very US centric, but actually the problem is not just US, it's world. And then within a month, this came out. The Executive Order 14228. You can tell I know this because this is a landmark thing in computing history. It's an exec order on how you improve cybersecurity for the US government. But personally, why is it just the US government? This should be for any global organisation or national. And what they said was, they put various things, you can go and read it if you want, but generally they had, we need to improve supply chain of our software. All our systems have software in them, but we don't know where it's come from. Is it being looked after? Is it vulnerable? Who's producing it? And we have no chance, it's a black box. And we can't have an organisation that's exposed to all these unknowns, because this is the risk. Because US government are a target, as we clearly expect, and they want to make that target as hard as possible. So we said we need greater visibility of our software. So it's all about called software transparency. And the other thing is they wanted an Energy Star thing. I've never seen this. So think about you when you go and buy your white goods and you've got your ABC, whatever, or your house. It wants to be able to categorise your software, so when you go and download your software, oh, it's a C. That would be really interesting to see if that ever happens, but I haven't seen that yet. There are some things that are starting to appear that's maybe given that idea.
Is the UK's National Cyber Security Agency doing anything?
Wait, a few slides later, we'll get there. But yeah. Before I tell you the solution, I'm going to do a little diversion because these all have a little bit of input in some of the problems. And open source software is there, as you'll see. So first of all, let's look at programming languages. Choose your favourite programming language. The languages in not italic are from the top 20 programming languages for jobs in January. Look at where the languages were invented. COBOL, 1950. C, 1970. Most of them in the 1990s. How many of those languages, let's just think even before 2010, actually took security as a key constraint within their programming definition? The syntax, the semantics. Go and Rust are now mandated for US government systems. They are memory-safe languages. 70% of vulnerabilities come from our little friends C and C++, which are embedded in most of our embedded devices because they are small and great for low-power devices. But the languages that are in italics, I know are language have got significant investments in systems that we all use today. Smalltalk is in Netflix. I think it was Netflix. Ada is in air traffic control. Erlang is in telecoms. Languages are all over the place, and these languages are not safe or secure unless you code them in a particular way. And those languages in green have what I'll call language ecosystems, which are good at actually managing the way the extensive library of other capabilities extend the language. Which is good, because you keep a language small and then you extend it, and you can benefit from that. But actually, look at the languages that don't have that are still major languages, like C, C++, PHP is running WordPress. So we have languages that are out of date, don't support the modern way we develop software. Then we have open source. So open source officially started in 1998. That's the official definition of when that open source little logo came. I had an open source conference, 2 open source conferences this month, and some great stats. 96% of all tech stacks are built with open source. So where would we without, so your Kubernetes, your most operating systems are built on open source. Where would you be? UK is a great developer of open source. We've got 3.5 million developers, apparently, which is more per capita than in the US, which is interesting. I didn't know that. But it's great for the economy as well, because it fosters collaboration. Lots of great innovative companies start with open source as their tech stack. It's where Facebook came from, where Twitter came from. And it's everywhere. So Alan Friedman, US government, part of NIST and CISA, OSS is everywhere. It runs our lives. It runs your Android phone. Where would you be without it? But we have a problem. And this is the classic open source comic, if you've ever seen this before. There's one little person who might write that really crucial little bit of software that everyone uses. Nobody's met him or her. And we dare change it because we don't know what will happen. Lots of businesses is the way they develop software like that. I've seen lots of variations about it, whether it's Nebraska, whether it's anywhere. That's the problem. People don't just build things on top of each other and don't understand what that foundation is. So open source is a real enabler, but Predace's got to be used in the right way. If you like your risk management, you've got ISO 27001, which has just been extended. And I look at what the supply chain is. I had a good chat with someone last week about where the supply chain is. Operational security. How are you doing patch management, vulnerability management, change management? How are you looking at your suppliers? How are you acquiring systems? These are all things that should be key things at managing your software and software risk. Rather than just saying, well, my son just wrote that little bit of application, and it seems to work, we'll use that. Lots of little small businesses end up like that. Can't have that. Unfortunately, I think A11 onwards are optional. They're not mandated as part of the 27001 thing. But if you do software, and have software in your business, why aren't you looking at that? Because it's part of the supply, it's part of your business. It might not be visible, but they are part of the greater part of your business. And then let's look at dependencies. And this is where it gets quite interesting, by those language ecosystems that have dependencies on third-party products. And then we have this concept of a direct dependency where you are actually explicitly using it in your software. Think like you're calling the function. And then the transitive ones, which are the ones that are the baggage that's brought with them. And depending on your language will depend on how many of those transitive hidden dependencies you get. Some languages are really bloated. You get so much more, your code base suddenly grows from 200 lines to 200,000 lines, 400,000 lines. That's the growth. That's your attack surface. There's different ways, there's a few challenges in terms of where you explicitly, do you fix your version of a thing? So I know version 1.2 is the version I know because I know that works. What happens if version that gets a bug and you update the build system? How do you change, how do you manage that? You need to think about that, and you can get conflicts. Because really what you end up looking like, these are different ways of specifying it. Different languages have different ways of specifying it, and you can see there's a quite complex syntax. Let's not dwell on that. That's what you normally get. That's a tree. So this is an application I'm responsible for. The red is my application. We take in about 80 blue things, which are the directs. We get another 40 odd packages we didn't ask for, we just get them. And when we start looking at some of them aren't maintained. But I don't know. Well, I'm not asking that. I'm looking at the due diligence I did was at the direct ones, not the indirect ones. So that's a problem. And most people have no visibility of this. If you're lucky, your architect may not understand the directs. When they suddenly get to this level of thing, they say, "Ooh, interesting."
Is it the software developer that should be responsible for this, or should it be the end user auditing the software developer?
We will get to that. We'll get to that.
Preempting things.
You've seen my slide before. Right. So the answer today is software bill of materials. So if you've ever come from an engineering thing, you might have come across bill of materials. When you're building a widget, you get a bill of materials, bit of components. When you're making a cake, you have a bill of materials, you have your ingredients. Software bill of materials is your list of software ingredients. But the way I generally do it is, my analogy is a burger, because I can tell you more analogies around it, the burger. So when you go into a restaurant, what's the first thing they ever ask you?
Have you got any allergies?
Have you got any allergies? It's before you even sat down. And why do they ask that? Because they don't you don't want a bad reaction. They don't want a bad reputation. Because the consequences of that can be quite serious. So when you look at that, do you know where the meats come from and all the rest of it? Because actually, that's what the chef's got. Hopefully he's got a set of fresh ingredients. Because every ingredient has a sell-by or use-by date. Yes? And when you go to a restaurant and you order a burger, there's not many different combinations. Do you have lettuce, do you have your tomatoes, all the rest of it? Actually, you need to track each product, just in case it's a problem. Let's look at that for software. Those are your software components, your frameworks, your libraries. They have use-by dates. They're called support dates, end of life, end of support. So you want those, that's your fresh. When you put them together, that's your configuration. That's like your meal. You need to maintain that and know where that's gone, in case, so you can keep track of your product. So software bill of materials allows you to keep track of where your components have gone into your software product. And it's electronic because you want it to be shared with machines. Don't write it down, and especially don't just put it in a spreadsheet. Put it in a form. There's some formats that are now international standards you should follow. You want to describe your software in a structured way that allow people to then analyse it and find insights into it. We'll see some of the insights later. You want to share it within your organisation. So is it your developers sharing it with your QA team, with your governance team, etc.? Do you want to share it with the end users, which are required in some jurisdictions now? But this is all part of software risk or business risk. So let's think about what that risk could look like. We've seen what happens if somebody get a vulnerability and you want to be able to answer the question. Now, this will help. And I've been following this probably for nearly 4 years. There's a lot happens. US started thinking about this in 2018, slowly, and then a few things happened that moved them along. SolarWinds just before end of 2020. You saw about the exec order in 2021. Log4j at the end of 2021. If everyone had had S-bombs in 2021, Log4j, no one would have batted an eyelid, because it would have been so easy. Linux Foundation looked at the state of the industry to see were they ready to embark on delivering and supporting software bill of materials for their applications, primarily looking at the federal market. Out of that came a few lessons, which then ultimately ended up with an organisation called the OpenSSF, funded to quite a healthy tune, millions of dollars, 50 plus million of dollars, to start educating it, of which SESBOM Everywhere was part of. Let's educate the market, let's write tooling, let's ensure people embrace it, and been part of that initiative. Europe then decided, well, what the US are doing, we probably need to do something similar in a European way. So there's something called the Cyber Resilience Act, which has taken some of what the US have done and have put a lot more legislation around it. And the UK consulted 12 months ago about what we should be doing. Last October, any medical device manufacturer, MDM, selling a product, a medical device, so think about, the things you get plugged into when you're into a hospital and goes beep, has a lot of software in it. Every piece of software that was then has to get approved by the Federal Drugs Agency. They had to provide a list of software components together with an assessment of the cyber resilience of that product. They'd never had to do that before. They'd been asked, would you like to do it? And they haven't done it, so then it was made mandatory. That's quite a big step from where people were, it's a black box. Medical devices have got operating systems, they've got embedded, most of them are embedded Linux or Windows type devices. And they have software, but they have browsers and all. Nobody knew how it was constructed, we just acquired it and built it in. The focus was on the medical benefit, not the technical risk. So that's a big step forward. UK then came up with a response last month. Basically they said S-bombs are okay in certain circumstances. I don't agree with that. I think S-bombs have value everywhere because software doesn't, a lot of the shell didn't say, well, I'm only going to be vulnerable if I'm in a defence environment. I'm not going to be if I'm in a retail environment. Software doesn't care where it is. Vulnerability is a vulnerability. And the CRA will become law later this year, which will mean in 3 years' time, any software product that is used in Europe, EU, will have to have a full assessment of all the software components they have in that build and maintain it for 5 years. So this is CE marking, for those familiar with CE marking on hardware devices, for software. A massive change to what people have had to do. If you were doing secure by design, it should be no problem.
Are you saying there then that if somebody in the EU sells some software, they have to maintain it for another 5 years?
If somebody sells a product that is sold in the EU,
yes,
and has software within it,
yes,
that software has to be maintained for 5 years.
so it has a minimum life of 5 years.
Minimum life. So if you go to the car industry in Germany, they've extended, so when a car has a production line, it ceases it on the production line. German thing is now 15 years, you have to support the software for 15 years after the end of the production line. And the car has a tremendous amount of software in it now. And that's a big problem for them. So it's a big change. So that means every device has to be updatable. Which is going to be very interesting. But fortunately we have standards. We have two competing standards. On the left hand side you've got the Linux Foundation, which is SPDX, and they came from a background of looking at licensing compliance for open source software. On the right hand side you've got the OWASP community, which has come from probably the more technical side, looking at, traditionally it was web, but it's now just any application software. And actually that came out from the back of another product, it sort of emerged out of the product, which you'll see later on. You can interchange them, but they all have strengths. As it then stands, there's two standards, there's strengths and weaknesses. SPDX has got people like Microsoft and Google behind it. Cycling DX has got people like Lockheed and IBM and Siemens behind it. So you've got big industrial people who are taking real good value as stakeholders, ensuring this delivers the value they need to deliver to their customers. And all it is data. So you have some metadata, which is saying who created the document, where, when, what. Specification of that, components and relationships. Don't worry, I'm not going to show you all the data. But who should be interested? Well, I'll turn around, who shouldn't be? If you're a developer or supplier or integrator, we saw early on, you should be producing them. And if you're producing them, you should be using them, consuming them. End users could consume them because that will allow them to understand how they react. So, for example, if there was a vulnerability and they had the knowledge, they could understand what's the risk of that. Do they stop production? Or do they, they can make some quite big strategic decisions. You've got people in development, products, as well as compliance people. Each of them are managing risks in different ways. And that's your life cycle. And throughout that life cycle, you are adding value to your software. As your software goes through, starts from design, then you start a bit of code, then it becomes built, then it goes into test, then it goes into release, and goes around the loop. And that's recognised in SBOMs by having different SBOM types as you go through your life cycle. So and you build your bit, you can have an SBOM that just identifies all your source files. Gives you some integrity. Then it goes into a build process. Then you can work out which version of the source files created that build, etc. Down to the level of what's actually running, because you may have software on a disk that's never actually run. Well, that might be quite interesting, because you may say, have you increased your risk because you've got software that you don't need, or is there software that's appearing on there that you didn't expect? So it's a life cycle, and apologies if this gets a bit techie. An SBOM starts with a generation process. So you can generate a process and its data. So you have checks, you can have checksums, a type of file, it's a file name, a bit of information. These are examples from me, so that's why I appear on them. It might tell you the license. These are all important information, bits of information that people could use to help secure your software. Or you can get more information from where you download it from. But don't think all generators are the same. This is a leaderboard. It's embarrassing who's at the top, but this is looking at how much data is actually included for your component. The specifications provide quite a rich set of data. They provide a minimum set, and people will just try and do the minimum set. I believe you should do the maximum. The maximum amount of data you've got gives you the greatest chance of people being able to analyse your software and get the greatest confidence. If you hide stuff back, that doesn't give a good impression in my view. And so you look at some of these most of these are open source, but it just shows these are things. Some of these are actually very extensively used and are assumed to be the best. Well, they do leave a bit to be desired. So then you can do some analysis. So you can find, I'm using the latest version of software. That's quite a nice thing. What's changed since the last time I generated an SBOM? What does it look like? This is a more readable version of that hierarchy. And you can start looking at licenses. And to start licensing, the licenses are all the same. But actually, you can start looking at this: have I got a license problem? Have I got a GPL license somewhere and I've got an Apache at the top? Well, that's not valid. Not everyone is familiar reading XML or JSON, so therefore it'd be nice to make it pretty printed so people can actually understand the information. It's probably easier to give that into a CISO than it is to give a stream of JSON. And you might want to store it somewhere, and then you want to interrogate it, and then you go and ask, when log4j comes along, you can just say, search for the log4j, oh, it's not there. Yeah, great. That's the happy day scenario that you want to be able to get to. But you can also search for things. Oh, they've got different versions. In that case, they've got 2 versions of PyYAML. That might be interesting. That might be an indication when I need to go and update that product or project. And this is something I did. I gave a presentation a few weeks ago, and just preparing it, I'd installed some software in a completely clean image and expected all the latest versions of all the packages to come. And then I ran this tool called an audit, and he said, and I say it's not the latest version. And that was because buried down in those deep dependencies, someone had actually what we call pinned a version of RSA, only 4.72, not the latest version. A bit more digging, I find out the software says not to be released outside organisation, so it's inverted commas, it should never have been released, that piece of software. So that was quite useful. I was never aware, I was never aware of that until I started doing this analysis. If I didn't have an SBOM, I wouldn't have had this insight. And this is what I started looking at a trend over a year. What we found interesting was, what's that little dot there? 27th of November. What happens at the end of November in the US?
Black Friday.
Black Friday. And Thanksgiving Day, Thanksgiving, whatever it is, yes. That's interesting. That week, 10 software modules got updated. During holiday seasons, lots of software sometimes gets updated. Oh, I'm not at work now, I'll basically do a bit of, I'll update some software. Interesting. And I think what's that one? That's beginning of the summer. That's Easter. There have been historical things where software features have been added at Christmas. Because, oh Lord, we'll just do something. Yes? That's interesting. Those 3 peaks are all holiday times. To be aware. And then this is a thing I just looked at. How frequently packages are changing. That one is changing every week. Why are they changing every week? So this is the danger about fixing your versions of software or not. So it's just quite, that's what you'd hope. Hopefully things are relatively stable. This is open source. This is the world of open source. These are all open source packages. People will change open source when they feel like it. Some will get bored and just, okay, I'll add another feature. What does it mean? And you can start seeing, the software not being maintained, which is a bigger risk. Why is it not being maintained? These are the red ones, but in this case we're saying there hasn't been an update in at least 2 years, which is, I think, a reasonable measure of saying is the software being maintained. Out of that, we then found out one of the packages had been substituted, was no longer being maintained because it was now part of the standard Python language. So that's why it was no longer maintained. So that was then, okay, we now need to change the way our code is doing to use the language version when we're using the latest version of Python. All good insights. If you don't know what software is, you've none of these insights. Then you might want to prioritize it. So this is maybe just one of the examples you might want to do is prioritize your vulnerability scans. This is a tool, came from OWASP. They've got a whole load of very good tools. That's probably too detailed, but basically what it is let's look at an SBOM and then look at various data sets and work out where the risks are. And then you go and fix your code. And then you go around again. Because once you fix your code's changed, you need to regenerate, and off you go. So you've got there, everyone's involved. So go back to the earlier question, who's involved? Product people, dev people, governance people, build people, ops people, CISO, C-suite, organisations getting oversight. Why wouldn't you be doing this?
How would a small business do this?
Right. Yes. Well, a small business, everyone will have, there will be people who have multi hats, won't they?
Yeah. And very little time to do stuff.
Very little time. So therefore, this is where automation. This is why the automation is saying. So you've got a CI/CD pipeline, which is part of your build process. There's a lot of tools you can plug into your CI/CD pipeline will do a lot of this work for you. Okay. But you need to have that grown-up, modern dev approach, DevSecOps approach. Because that's the way software should be done. If you're doing a secure development lifecycle, which we're all doing because that's what the NCSC tells us we should be doing secure by design, all these things are things you're doing throughout the lifecycle, and the SBOM is going to help with all these checks. Because it's going to tell you, when you select your library to use, you've already done an assessment of it. Is there vulnerabilities in it? Is it up to date? Is it being maintained? These are all checks you're doing all the time, aren't we? Or maybe we forgot. Because we were too busy doing other things, writing features. So if you can do this and automate a lot of this and get the trigger points, then you're not going to get obsolete software, which goes back to the Equifax problem, because they didn't have their eye on the ball. So the insights you're going to get are what components you've got, how you're using them. Are they being maintained? And are they vulnerable? But going back to the open source world is a community. Most of those communities are full of individuals who are not paid. If you are in that, going back to that original little comic thing with the guy from Nebraska, who's funding him? He needs to be loved. If you are reliant on his bit of software, it's business critical and it goes wrong, he could just say, I'm not interested. He needs to be loved. So how are you maintaining? So this component, look at these components, we'll work out where those components are and how dependent you are. Let's look at dependent licenses. Licenses are a big challenge. People don't do it. Ultimately, this is all about security and resilience, which is really where the US came from, where the EU are, where we should be. Right, there are challenges. Licenses are all over the place. Metadata is a shambles, to be honest. It could be better. We're not consistent in naming products, particularly when products get taken over and moved over from one company to the next. We're not good at being consistent at doing versioning. There's a style called semantic versioning where you have major, minor patch, 1.2.3. It'd be good if all software maintained that. Microsoft, it's 22H2 or whatever, isn't it? So try, it would be good if the versioning was easy, because that version might not be actually reflective of the software, because people will use the same version of software, but it won't be the same. They may have changed the software, they may have recompiled it, but not changed the version number. What's that? Quality, you've seen about quality. SBOMs is a challenge. Have as much data as you want. Be careful of who's going to use these SBOMs. These SBOMs are useful. They don't reveal your IP. That's one of the threats I hear, is people, this is going to tell my competitors what software I'm using. Well, actually, if you get a list of ingredients from Coca-Cola, you get that on the can. That's not telling you how you make the can of Coke.
It is useful for the hacker though, isn't it?
Not always, because you don't necessarily know, it's not giving you which bit of that component's being used. It could be.
It's another
It's a bit of information. Yeah. Yes, it's a bit of information that we might not have had. They can already get this information. They already have SBOMs because it's called reverse engineering. They reverse engineer the code. So, and this is just data, so you need to look after it. SBOMs don't live on their own. Software doesn't live on its own. Software needs hardware, it needs firmware, it needs services, it needs operations is system of systems terminology. We have the world of AI with ML. ML's, a few slides later, we're going to talk about ML. But you've got cryptos, you've got manufacturing. What are the things? If you've got particular components that are bespoke, then that's useful to manufacture them and work out, well, how are they then integrated into your system? So think about this as other things. I'm aware Lockheed are doing this for something like the F-35. That will be it. Just think about the amount of layers that is. Their supply chain is global. And you've also got to think about, well, you're thinking about security, about signatures to make sure that it's signed, make sure it can't be tampered with, and there's various other things we're going to talk about next in a minute, which is about how you manage vulnerabilities within your SBOMs. Because when you have an SBOM, it's a baseline, it's a moment in time. And vulnerabilities appear continually. So you can continually look at, well, given your SBOM, does that vulnerability actually have an impact on my product? Is it really exploitable? In a lot of cases it won't be, because it won't be exploitable because the conditions for that exploit or vulnerability to occur don't occur in your instance of your product. For example, it can only happen if you're going outside the internet and you've got a big firewall in the way, so therefore it's not going to happen. But a lot of the SCA tools, software composition analysis tools, will not recognise that, so they'll be very noisy and they'll give you lots of work and say, oh, you're vulnerable, you're vulnerable. VEX is a way to try and take that workload off you as part of that triage process. So you just need to look at these impacts. That's a new process. No one's doing that. That's a new thing that's just coming out. And SBOMs can be used for lots of things. We talked about vulnerability, we talked about license. It can also be talked for lots of things like M&A. I talked to someone last night about mergers and acquisitions, how they're using it as a really great way of a part of the due diligence process to say when a company is acquiring it, are they using up-to-date software? Have they got a lot of technical debt? Have they been applying to licenses correctly? So it's really quite a good insight, a quick way of getting that. Similarly for escrow, regulatory compliance is just going to grow. So every presentation now has to have, what about AI? It's just software. So we need the same. But there's more. Because AI has more risks than just software. Come on. What's the data that's going to be AI? How do you describe that? If you describe the data and then you look at the use case of your AI model, the data was say looking at people in America and you're going to use it in Europe, it's not going to have necessarily the right data set. AI needs to be as transparent as software. In the same way SBOMs are giving it for software. So this is something we need to start, and this is only just starting to emerge. If you go to Hugging Face, some of this data is available, but it's not really visible. So if you've got AI as part of your software component or product, also think about getting the transparency of that, because that's the next thing is people are going to start assessing. AI is going to make decisions for you. If you can then understand that those decisions are right, then that will help. And you can get vulnerabilities in AI, of course. So there's organisations here to help. OpenSSF is heavily funded by big tech, companies like Google, Microsoft, VMware, and they, which has got Alpha Omega, looking at things. This was set up following in the US 2022. It was when it got really kick-started, when a month after Log4j, all the big tech got summoned to the White House and said, what we're going to do about this is not good enough. So they've set up various working groups looking at how we can improve the integrity of the supply chain, better tools. What are those critical open source projects that everybody relies on that's not being maintained and funded? And how do we secure repositories? So to stop things like people hijacking the repositories. So one of them in supply chain integrity is something called SALSA, which puts checks throughout the build cycle. So going from the source to the build, there's check integrity. So if there's any ways of interjecting or disturbing that, it's detected. SALSA came through IBM. I think IBM started that. It's continuing under development. And then there's S2C2F, supply chain. This is Microsoft's view. Microsoft trying to look at how they secure their software coming in from third parties and how it goes through their build process, such as the short, but what comes out of the Microsoft build process, which is complicated, is right. And they've got a life cycle around it in terms of how we do it and how we rebuild and how we fix and how we do the patching. You know, good that Microsoft is recognising this and they're giving this to the world. There's 150 projects that have been identified as critical. So, for things like Linux, for obvious reasons, because it's everywhere, OpenJDK, OpenJava, Python, Ruby, GCC, C compiler. The projects have come from various sources. Harvard did a study a few years ago looking at criticality of the software, open source software. Google, Microsoft and Linux Foundation, being like Kubernetes, are key these days. So therefore, those are being contributed. Ultimately, this is to try and work out how we get funded to maintain and make them more secure. Most software, open source software, is not funded. You may find Google, Microsoft, Red Hat are contributing to the open source software, but they're just contributing to it. They may be particularly looking at security fixes, but actually generally the features, driving features. So one of the things you're starting to see now in Europe is governments are starting to recognise that the public sector is dependent on these projects. Let's give some money just to try and make them better and more secure, because we don't want to be left embarrassed if something goes wrong. So Germany and the Sovereign Tech Fund are giving €10 million a year. Netherlands just about to do it. EU have got, I think, $20 million across the community to try and do this. It would be really great if every G20 country gave £10 million a year just to fund this. It would save everyone, 8 billion people would benefit.
How do you ensure that that guy in Nebraska is writing secure code? Because if he is writing really insecure code, that's a massive vulnerability then, isn't it? And I'm guessing that's a weak spot of open source software.
Which is what these projects are doing. So they're trying to look at what are the major infrastructures. So major infrastructures you've got these days are things like Kubernetes, for all your containerization, virtualization, and the operating systems, Linux, for the embedded. So if you're looking at that, and then you're trying to then build up the tech stacks such you don't have those little things, for any of these, OpenSSF have something called the scorecard, and part of that, for you to qualify for the scorecard, you have to have at least 2 different organisations contributing to it, plus I think 3 maintainers. So the project I'm involved in, we can't get it because I don't work for the company that owns the project, because I don't work for them, and we can't get that because they haven't got another maintainer. So it's that sort of thing to try and make sure it's not relying on a single individual. It's a team project. And, you know, look at Kubernetes. It's got thousands of developers now. I'm not a lawyer, but I feel duty bound to tell you that software is a liability. And I don't want someone to come down and suddenly say, well, my bit of software was the reason why I got hacked. So these are the sort of things that you can see, you know, what neglect of quality standards. Why is that important? SolarWinds, the CISO, has been charged for fraud and for being internal control failures, which is quite a nice phrase. So were they doing proper due diligence of their software? That's going to be a very interesting test case. That'll become case law. So at this moment, all the CISOs will walk out of the room because do you want that responsibility? It's no different in any organisation if you're taking safety. As a senior executive, you have that responsibility for the safety of not just your employees, but your products that are being used by your customers. So it should be no different. Security has to be seen at the same level as safety and legislation. And I'll go down to CSC. Yeah, there's things about supply chain guidance. Go and have a look at that. There's a whole lot of things. That information is continually changing, and that's one of the problems we've got to be aware of. They put something out earlier this month about vulnerability management that went from one page, it was one page, and then now it became 20 pages. So you need to keep on top of this. This is your useful guide. There's lots of other guides as well, but I've used that as a starting point. One size doesn't fit all, clearly. Right, nearly finished. Supply chain is not just about third parties. It's wider than that. It needs to be end to end, all the way through. And security doesn't stop with code. You need to look at the maintenance life cycle as well. Think about who your suppliers are. Know who your suppliers are. Love your suppliers, really, in software. They can do you a lot of damage if you don't like them. Yes? I'm going to say embrace software bill of materials because it's going to give you so much insight. And as a product manager, if you're a product manager, you love putting new features in, creating a new widget. Don't forget the maintenance and security are just as important, and maintenance of things like metadata of your products are really important to allow people to understand where it's come from. And for software vendor materials, they're really valuable at helping you manage that risk. It's a partnership though with your supply chain, up and downstream, and your users. So share, work with it. Don't beat them up when they say, oh, you're still using that version of software. Work with them. There may be good reasons why that does. If that gives you a problem, work with them to work out how to solve that together as a partnership. And it's got to build trust. Increasingly, you're going to say, can you give me your SBOM? If they can do that by email and say, here it is, in half an hour, that's a really good sign because it shows them control. If they say, what's an SBOM, that's probably going to give you a bit of a worry. And they say, well, it takes a week for them to find it, that's even worse. This also affects into solution procurement. When you are starting to procure software, ask for software bill of materials to be made available, and then make it, share it, work out who you can share it with. It's no different to any commercial document you have anyway. You wouldn't share your contract freely, so just think about it as a contractual document. Support your key suppliers. Be realistic. Don't say, I don't want any vulnerabilities in your software, because as soon as you say that, 5 minutes later that won't be true. Be realistic. Fixing vulnerabilities needs to be driven on a risk-based approach, not just a numbers-based approach. Because the risk, not every vulnerability is going to affect your risk. And be aware of regulation. It's going to change. I hope it's going to become global rather than national, but watch this space. There's these two books came out last week. So they're starting to now communicate, people are now starting to share their experience. Cassie's a VP in Schneider Electric Energy, whatever it's called in. So she's got a worldwide team across 80 countries managing their supply chain. Think about PLCs, think about electrical supplies, think about big systems. She's got a wealth of really good experience, very good friend. And Tom has been driving things in the States as well. I know Tom very well, and I'll help review that document for him. So that's really a bit about the history and what some of the challenges are. So those are two very, get them from your normal bookseller. And if you want to listen to me again, I've given two talks this month. One was at State of Open, where I was talking a bit more about why we needed SBOMs, and at FOSDEM a few days previously was some of the more technical things that I was finding. So again, those are available for you to enjoy. And that's it. Thank you. It's not bad. It's an hour.
I have a question.
Please do.
So I probably should have started the day by saying I'm not techie, I don't do coding, I don't get involved with that side of it at all. I'm a business analyst, so I help businesses procure software.
Good.
Obviously, as a standard within requirements catalogue, there's things like GDPR compliant, records management compliant, where your data centres are, ISO 27001, Cyber Essentials Plus and such like. Is there anything in addition to things like that that would give a business protection against things like this if they don't have an in-house IT team to be able to understand what an SBOM is or even how to read one to know what they're looking for?
So I think first thing is if you're procuring software, ask your suppliers to have, are they aware of what an SBOM is?
Yep.
And could they produce one for you?
Okay.
First thing. If they can produce one, then that's really good because it shows they're aware of.
You wouldn't need to understand it, it's the fact that they can produce it.
So if you and it says, and if you have an issue, like a log to shell, get on the phone and say, you got the SBOM, are we affected? Yeah, if they've got that, they should be able to give you instantly. Yeah.
Okay.
If you then want, if you were then want to do an analysis of the SBOMs, get someone to come and do it for you. Yes? And then make a thing. I might do that. To do an audit, it's just like an audit. 27,001 might touch it, but this is probably deeper than 27,001 and this will go.
That's what I was thinking of as you were going through.
Yeah.
It feels as though it's more detailed. Therefore, if you've got a company who are procuring and are going, well, you're a supplier, you've got your cyber essentials, you've got your 27,001, and therefore you're safe. But are they safe?
No, you're not. You're not, because just if you go to Cyber Essentials, it just says, are you managing vulnerabilities?
Yeah.
Doesn't say, well, it can say yes. Well, how do you know that it's managing the right vulnerabilities? How do you know it's managing all the vulnerabilities?
Okay, yeah.
So therefore, have you got things? So people I know who are going through this journey are finding there's a lot more they didn't know. So this is the Rumsfeld approach, the unknown unknowns.
Yeah, because obviously a lot of organisations now, they're relying on cloud-based SaaS services, and therefore they're putting the reliance on the supplier of the SaaS.
Amazon or cloud providers will get out of that because it's not, because basically they're just a provider, you're the procurer.
Okay, cool.
This is coming. So US, Europe are going to expect product providers to make them available on request to governments. So this is going to become, I would expect that whenever you're delivering a piece of software, in the same way you do a delivery note and a license, here's the bill of materials, or a bill of materials can be made available. And that would be, to me, would be a really good step forward in terms of taking, I don't like to say the professional approach, a resilient, rigorous approach to saying that we recognise the challenges we have now with software.
Yeah. Okay. Cool.
Yeah. As a business analyst, you're potentially, there's risk. Yes.
Yes.
Yeah. Have you done a risk of you must be doing a due diligence of your suppliers.
Yeah.
You're doing, are they financially viable, etc. So there's a company. So there's a company I know that does that. Looks at if they're providing software, let's look at the financial health of the provider of that software, whatever they do, to say, are they, particularly if they're critical, cloud, SaaS things. If that company disappears and you're reliant on their SaaS product, well, what's your backup plan?
Yeah.
So just think about it, not just the financial now, this is the technical side, and think about software. And I don't think many procurements are probably thinking about that.
And from my experience, that's exactly because I'm looking at this and going, this is all new to me, and obviously I get involved quite heavily with producing ITTs and stuff for going out for software procurement, but the organisations are going, oh, but the supplier is responsible for the version control and the patching, the updates, the DR, all this stuff, so therefore they feel as though they're putting all the responsibility back onto the supplier who they're getting the SaaS product from, whereas there should be an internal risk management and risk-based approach to know that what they're taking is actually correctly secured and certified.
Yes, and it's also, okay, if they're doing patch, do you know what patches they're doing? Are they patching the right thing? If they give you the patch, have you patched it? Have they given you, actually, when you buy a patch, that's a new SBOM. Because it's changed. Have you checked the integrity of that patch? There's so many, it gets quite involved. But I think you need to, I'm glad you're saying this is all new. We have time.
Yeah. That's good.
We have time. But actually, I think we can start benefiting this from now. I was talking to a very small company who was auditing their software process. And so we can produce SBOMs, don't know what to do with them. It's like, well, that's a good start. At least you've got the build process, the producing them. They're actually, the tool chain they have is already got quite a good approach. So they could able to check the pedigree of that. because the type of customers they want to do are going to need that assurance already. So that's the fact they're building that in from day one. It's a new product, great. The legacy products is the bigger challenge. OT is a massive challenge for this.
Yeah, it is. I was just thinking about that when making a few notes as we were going along about things that I need to do. Any other questions?
I think it's just, cyber essentials and all the ISO accreditation came in to solve the problem, and it just needs to be enhanced to put new guidelines in, doesn't it? Things that people need to check. I think one of the other things that...
Have you stopped recording?
No, I will stop. Tell you what, thank you, Anthony, for the whole thing. We shall hopefully see a lot more of this stuff in the future. Really enlightening. I've learned a lot. I hope everyone else has learned a lot. And we'll get this up on YouTube fairly soon. Thank you.
Thank you.